Welcome to SAT 0 to 1. Today we'll be learning about the standard deviation. Standard deviation, although sounds complicated, it's just really a measure of how spread out the data points are. Although you don't need to know the mathematical formula for standard deviation just for the SAT, but I just want to put it out here so you can know where it came from. If you don't want to know the formula, you can just fast forward this section. So in this formula, sigma is the standard deviation. x1, x2, all the way to xn are set of numbers. X bar is the mean of the set of numbers. N is the size of the set. I'm going to give you a quick example on how the formula works. Suppose we have a set of data 1, 2, 2, 3, 7. Okay. Then we can calculate the mean first, which is 3. And so the standard deviation can be found by substituting each individual data and the mean into the formula, like this. And we can calculate the standard deviation to be approximately 2.1. Notice that the value 7 contributes the most to standard deviation because it is the furthest from the mean. Let's try to find the standard deviation from a different set of data. 2, 3, 3, 3, 4 this time. Again, the mean is still 3. But notice how every number is very close to 3 this time, resulting in a much less standard deviation. Here are the graphical demonstration of our two sets of data. Notice that the data points on the first graph are more spread out than the data points on the second graph. So we can say that the first set of data has more standard deviation than the second set of data. Which means to compare standard deviation graphically, we don't need to do any actual calculations. We can just think about how spread out the data points are on each graph. In this example, we say that the data points on the first graph is pretty concentrated around 3 and 4. So it has the smallest standard deviation. The points on the second graph, however, is not concentrated on a single value, but they are not scattered around everywhere neither. On the other hand, the points on the last graph are everywhere, meaning that this set of data has the greatest standard deviation. Now we know how to compare standard deviations analytically and graphically. Let's take a look at a practice problem. So Mr. Han teaches 2 classes, each of which includes 6 students. The listings above show the test results in ascending order. Which of the following compare the score standard deviation for each class correctly? Okay, let's first calculate the mean of class A, which is 82. Similarly, we can find the mean of class B to be 81. Notice that the scores in class A are spread out from the mean. We have 49 as the minimum, 99 as maximum. Meanwhile, the scores in class B are very close to the mean, which is 81 in this case. So we can tell that the standard deviation of class B is smaller. And the correct answer is B. Okay, let's try another graphical problem. The following graphs are the GPA distribution from 2 classes of size 20. Which class, A or B, has the smaller standard deviation? Again, we can see that the GPAs in class A are all centered around 3 to 3.5. So they're not that spread out. However, for class B, the scores are distributed everywhere, so they are very spread out. Therefore, we can say that the scores from class A has a smaller standard deviation. And that's it for today's lesson. Thank you for watching. Until next time.